Hello, Chris Keyack here with Keyack Technology Solutions, and in this video today, I'm going to showcase how to do extended shear tabs on beams to wide flange column webs. Now, here within Tekla Structures, I'm going to go to the Applications and Components panel on the right-hand side of the screen, which is this button here on the toolbar. And in the search, I'm going to do a search for connection 186. 186 returns column with stiffeners 186. I'll simply activate the component by single clicking on it. At the lower left-hand corner, Tekla says to pick the main part, which is going to be the column. That's going to be the supporting member. Then it says pick the secondary part. That will be the beam or the supported member. So I'll go ahead and click on that. It applies my connection. And now that I'm all done with that, I'll right-click and interrupt to get out of that command. Now, we're going to see this green cone here, and when we highlight it, it shows us both near side and far side stiffeners are created that are lined up with the top and bottom of the shear tab, and then it creates a shear tab on the near side of the column web. Now, the problem here is that we want to get rid of those far side stiffeners because we have a beam that's a different depth on the other side. Now, to do that, we'll simply double click on this green cone, which will open up the component properties. And on the stiffeners tab, we're going to zero out the thicknesses of the top far side stiffener and the bottom far side stiffener. So when we zero out those thicknesses and press modify, we'll see that those stiffeners go away. Now, the reason why I had to do that is because here, if I actually remove those out and go back to modify, you'll see that the far side stiffeners are there again. A lot of people see this switch here to turn the stiffeners on or off. So if you do have a case where the connection design does not require those stabilizer or top and bottom stiffener plates, then you can just simply turn those off here in this switch. However, there's not a near side and far side option. And so if you do need the stiffeners on, but you only want them on the near side, then this is where you have to, again, zero out these two numbers here and then press modify. Now, there's already some starter settings here that Tekla has created in the US environment. There's a no stiffeners and stiffeners near side only. So let's go ahead and load that up, and you can see that it's already got the 0 filled in. So I'll go ahead and start with those, and I'll press modify there, and we can see that it has the near side only because these are zeroed out. Now, this switch, a lot of people think that this is because it looks very similar with the image in the picture here in the dropdown. But this image is not controlling near side, far side. This is controlling whether the stiffeners will go to the flange only or they'll also go to the web. So for simple shear connections, I'll usually just have the stiffeners go to the flange only. So I'll switch that here. So now that I've got that set, I'm actually going to save as with these settings and overwrite those into my model attributes folder. So whenever you do a save as or save, it gets written into the model folder. So what does that mean? If I actually come up here to the Tekla menu, go to Open Model Folder, and then here, if I bring this over, I'll go to my Attributes subfolder. So here, that Open Model Folder command basically opens you up to the Tekla model folder. Whenever you do any save as's on any of these dialog boxes, those settings are getting stored inside of this Model Attributes folder. Here, if I then do Sort by Date Modified, we'll see that stiffeners near side only .j186, J for joint, and then connection 186 is the file extension, and that setting is now there. Now, once I set these settings up, if I don't want to have to go through and do these again on another job, then I can just copy this over into my firm folder and reuse those settings. Okay, so that shows you how to take settings and update your firm folder. Let's go ahead and update a few other things here. Well, the first thing I can see is that I don't really need this top and bottom clip for this style of connection. So I'll go to the Plates tab and I will just zero out or clear out these corner clips, and I'll save as. Let's do modify, and that removes that. The other thing I can see here is probably the weld sizes need to be updated. So I have a lot of 1/8 inch and 3/16 welds. So I can come in here and go to welds, and then I can update a lot of those sizes and put specific values in here. So again, here weld number 5, for instance, in the picture below covers the shear tab weld. So if I do 1/4 inch near side and far side, then modify, that should update that here. So I'll deselect, reselect, and there's the 1/4 inch. So I'll go ahead and go through and fix all those on the rest of the welds, and then I'll save those settings. All right, so I've got the 1/4 inch filled in on everything. We'll modify, reselect the component. Yep, looks good. 1/4 inch near side, far side on the stiffeners and the shear tab. And I'll press OK here, and I'll save as to save those settings. Now I do have a no stiffeners option. So let's actually do that. Let's get rid of this here, this text, and I'll just do no underscore stiffeners. So on the basically here on the stiffeners tab page, I'm going to turn this setting here to no stiffeners. And then I'll just come in here and I'll say 186 no stiffeners. And that way we can just keep kind of the other settings that we had. And then for the stiffeners near side only, if I load that up, you'll see that it says near side stiffeners. Now this is going to become important here on the connection code in a moment when we auto connect this. All right, the only other thing that I might cover real quick before we use auto connect to apply these in here. And in fact, you know what I'll do is for no stiffeners, let's do stiffeners near side only. I'm also going to save this as standard. Let me show you why I'm going to do that. So if you save anything in Tekla as standard, then basically that's going to be the default that is loaded and applied until you load or apply something else whenever you open the model. So if you forget to load something else, then standard is going to be your starter settings rather than kind of like the Tekla defaults there. All right, so I've got that set. Now, the other thing that I'll cover real quick is on the bolts tab. If you've got an erector that says, hey, I don't want any short slots on beam to column connections, because maybe they don't want that carrying over those slots across the bays and it makes it harder for them to plumb up the building. Just depends on the erector you're talking to. I just want to make sure that you all know that on shear tab connections, the US environment by default has short slots turned on in the shear tab, and that is right here. So here there's a 3/16 short slot because 3/4 inch bolts are used by default. You'll see that it says slotted and that the slots are in the plates. So if you do not want that, you can just zero that value out and leave these settings alone and you won't get any short slots. The standard 16th oversized hole or standard hole size will be created. So whatever you need there. Now, we've got our settings saved away. Now what I'm going to do is I'm going to move on to show you how AutoConnect works and why I use 186 at both the flange as well as the column web for simple shear connections. Okay, so I've removed all of my existing connections here. I'm going to select all of the steel involved in this framing condition, and I'm going to go up to the Edit tab at the top of Tekla here on the ribbon. I'll then go to Components, and then I'll choose the Create Connections option. Now when I do this, I'm going to switch this to shear tabs for both the auto defaults and the auto connection rule group. Now when I do this and say Create Connection, you'll see here that it automatically generates the connections and it knows to automatically apply connection 186 with the near side stiffeners only. And then over here, you can either choose to tell this to apply connection 186 with no stiffeners, or you can use the typical connection 146 since that's a simple shear tab connection there. And that's what it looks like the Tekla rules have done. Now let me redraw and explain why this is pretty handy. If I come in here and go to the column, and let's say there's a design revision, and I switch this from front to top, so that way the column's rotated 90 degrees, look at that. It switches from connection 186 to 146. Now, I don't seem to remember Tekla actually automatically changing the connection number, so I'm a little bit surprised that it actually did that. Usually it would keep the existing connection 186 there, and you would tell it to just load different settings that don't have the stiffeners turned on and off. But watch this, I'm going to undo. You'll see that this is clearly 146. And then when I redo, you'll see that now into that web, that's connection 186. So that's interesting. I am not used to seeing that, and I don't seem to think that that used to happen in older versions. I'm currently in version 2023, so that is a desired effect here if that's exactly what I want to happen. But usually I used to have 186 applied at column webs and flanges, and then I would just change the settings to load up stiffeners when required and no stiffeners when not required. However, let me explain how this is working and why that's super handy and what it just did. If we come up here to the Tekla menu and we go to Catalogs, there's Auto Connection Settings, and then we'll go back into Tekla menu, Catalogs, Auto Defaults. Auto Connection here on the left. If we go to Shear Tabs, what this does is this says what connection number to apply at different framing conditions. So for beam to column flange and beam to column web, we can tell it which connection number for different rules to apply at different locations. Now in this particular case here, the default beam to column web It's just applying a column with stiffener 186, which is exactly what we did. And that's exactly what we see here. Beam to column web, it applied 186. Then here for a beam to column flange, it applied 146, which is exactly what we saw it do. So auto connection tells Tekla which connection numbers or joints or components to apply at different framing conditions. Now, auto defaults takes that one step further. You'll notice that underneath where it says shear tabs here, there's all these different component pages. Now, to go find connection 146 without you having to hunt that down and 186, that is here underneath components 17 tab page. So here is shear plate simple 146, and then there is column with stiffeners 186. Here you'll see that there's a 2-column web. It's telling it to use stiffeners near side only. Here underneath default, which has basically got no rule, it's the leftovers, it's telling it to use no stiffeners. And this is exactly what I expected, to have 186 applied at the flange and the web, and no stiffeners applied at the flange and stiffeners near side only at the web. Now, let me just right click and say edit rule set on this 2-column web. Basically, this is saying if the rule here, these are all your rules you can choose from on the left, and there's 2 rules being applied in here. Here we're saying if the secondary beam is framing to a column web, and that's true, if that's the framing condition, and the profile type, I guess it looks like it's a number here, usually that's a letter, but if the primary profile type is like number 1, which must mean that it's wide flange, then essentially this rule of beam to column web is going to be true, and we should use those near side stiffeners. So that was a little crash course on auto connection and auto defaults. Again, remember, auto connection is saying which connection number gets applied. Auto defaults is which saved settings or attributes are being applied. So see here where it says stiffener near side only, that's true with this particular rule. And if I double click on this, these list of saved component settings or attributes is the same thing as me coming inside of the dialog box and choosing which of these saved settings that I've saved away here. So again, no stiffeners, stiffeners near side only, stiffeners near side only, and no stiffeners. So basically you're mapping which saved away settings or defaults that you've saved away, and you're mapping them to which particular framing condition that you want them to use for that particular connection number. Now, I do want to show you what I was talking about of using the same connection number 186 for both the flange and the web and how it just loaded up different attributes. So I'm going to show you what I mean by that. So here where it says beam to column flange, rather than using 146, watch this, I'm going to change this. So I'll type in 186 here and we'll choose that. And so for the default coming into the web and the flange, we're going to use 186. So I'm going to press apply and OK on that. Now coming over here to the auto defaults, because we've got the no stiffeners by default, if I edit this rule set, there's no rules here. So the way that auto connect and auto defaults works is it reads the rules on the top first, then it goes to the next rule if this returns false. So you want the more restrictive or specific rules to be at the top of the tree and then continually go down, where here default, which is like kind of like the leftovers, is at the bottom. So if it sees it's going to the column web, it's going to apply stiffeners near side only. And if it doesn't see that as true, then it's going to basically use no stiffeners. So I'm going to say apply and OK. Now I'm going to try to actually just change this here without having to delete the connections, and let's see if this works. So I'm going to say modify. Now it looks like it worked. Let's see. This is connection 186. Look at that. It did not leave that at 146. So again, this is how you used to do it in previous versions of Tekla, where Tekla would not actually change the connection number. Again, I'm a little bit surprised by this, that it actually deletes out that component or modifies the entire connection number. But this is how it works. See how here connection 186 is being used and no stiffener properties at the flange. And then here in the column web, connection 186 is also being used. But then on the general tab, we can see here that near side stiffeners is being used. Also, another way to see which rules are being applied by auto connect and auto defaults is if you click on the cone, right click and say inquire, it'll actually show you here which rules have actually passed. So here it says this is the attribute that was used. It passed the default auto defaults rule group, and then that tells me which settings were actually loaded for that particular connection. And again, just to switch this back to top and hit modify, we'll see here that now this one coming into the web is connection 186, but it is using the near side stiffeners only. Now, the last thing that we're going to cover in this video is the stiffener plates and their widths. If I actually change my selection down here to objects and components at the bottom of Tekla, we will click on this stiffener tab and I'll right click inquire part, and this will tell me what the profile is. So if I scroll down here, we're going to see that this is plate 3/8 by 3 15/16. Well, this is a simple stiffener. I probably want to make this out of bar stock, so I don't want to have to necessarily burn this on my burn table. And so instead of 3 15/16, I want that to round it to 4 inches. Well, there's a setting that actually controls this. So here within Tekla, if you look into the Tekla user assistance, there's an advanced option called excess standard stiffener width tolerance. And there's also one for gusset plates as well for bracing. But this shows you that all of these connections, including connection 186, will actually read from this setting to round the stiffener widths. So where is that set up at? Let's go to advanced options, settings, advanced options. And when we bring that over here, let's go ahead and type in excess_standard, and we will do a search in all categories. There we go. There's the two settings, one for gusset plates and one for stiffeners. Now here you'll see that the stiffener width is set to 6.35. That is 6.35 millimeters, which means that stiffeners are being rounded to the nearest quarter. And, you know, if you think about it, on most column sizes, probably 8s, 10s, 12s, 14s, you're probably going to be having bar stock that has either half or quarter-inch width increments. And so that's why it's set to 6.35, rounding it to the nearest quarter. Okay, so now that shows you where the setting is at and what's affecting this. And you'll even see that it's actually trying to pull that back. It's not having that stiffener right to the toes of the flange. However, why did I get 3 15/16 instead of 4 inches? Well, this is actually something unfortunate with this component. Again, this is something I've asked the support team to look into and add this to be hopefully modified on the component. But let me show you and explain what's happening. If I double click on this component, go to the stiffeners tab here, what's actually happening here is that it is assuming that the shear tab is going to be going into the column web. So watch this. If I load up stiffeners near side only, we have this set here currently to actually be going to just the flanges only. But if I switch it back to the web, hit modify, and then I change my selection to objects and components, if I say inquire part, this is going to show that the plate is plate 3/8 by 4 3/4. So it did round it to the nearest quarter inch, but it's assuming that it's going to the column web. So unfortunately, this rounding calculation that's happening on this component happens before it sees that it needs to only go to the flange. So it's just one unfortunate thing here related to this. And that's why I'm getting that strange kind of number. Now I'm going to switch my selection back to components. I'll select on this. We'll modify it back to go to the flange only. And so a lot of people are like, well, okay, that kind of sucks, but maybe I'll just come in here and I'll force the value or the number. So they'll come in on this and I'll type in 4 inches and say modify. Well, look what happens. It decreases the width of that tab. And that's not quite exactly what we expected. And then so then a lot of people will say, well, maybe it's just this distance here. I need to zero these numbers out so it doesn't go away from the flange. And look, nothing happens. So again, this is a little bit strange behavior, and this is why I'm pointing it out, because a lot of people try to do this. So I'm going to put in 4 13/16 here and say modify, and then now it works. Now I get a 4-inch plate. So watch this. I'll click on the plate, inquire part, scroll down, and there I've got 3/8 by 4. Now, how did that happen? Well, again, it seems like there's some sort of rounding related to this stiffener going to the column web versus flange only. And so when I put that 4 13/16 in there, it looks like it's calculating the width of that tab to be that distance there, that 4 13, which is the measuring from the toe of the column flange to the face of the web. So if I select on this column, hold down Shift, show with exact lines, that'll show the K or the radius in there. And if I actually go to the properties of that particular part, so this W12 by 53 column, we can see that the rounding radius on this is set to 13/16. So there's that 13/16. That's where that number is coming from. And then this is 4 inch left over. So again, I've reported this to support. Please, if this is something common and you do want these stiffeners to truly be rounded to flat bar, add yourself to support and by asking them about this. Hopefully this will be fixed in future versions. But this does get asked a lot in trainings that I do. Like people want to force this to bar stock and they don't understand what's happening and why things aren't quite working the way that they expect. So I wanted to make sure that I covered this in case you run into this example.